All right, so continuing on with videos for week one. Here's another example from Bob Selmer's class notes. We have this piece with the mass at the end of it and two springs, and we want to find the differential equation of motion and an expression for the natural frequency Fn. As we have with a lot of the other examples, we want to draw an FBD and IBD pair. And anytime you have a situation like this, you kind of want to make it at an arbitrary angle that isn't 45 degrees. All right, so and these should be equal to each other. All right, so it didn't tell us that the bar had any mass. Here's an important thing. Well, we have to kind of decide. Does the bar have mass? It doesn't have mass. Let's decide it doesn't have mass. All right, so there you go. So they didn't show an M. I actually made the picture, so I don't know. It doesn't have mass. We can establish that this thing here is the angle theta of the thing right in there. At that instant, I didn't leave a lot of room for myself, so I'll rewrite here, mg, okay. And this is going to be, we're going to use a small assumption of a small displacement here, so small angle. So here are two forces. One's going to be Fs1, here's Fs2. It didn't quite say whether there was a preload in here. We could assume maybe that the springs were neither in compression or tension when they started. If it's in this position, K1 is pulling on it as a tension, and K2 is pushing on it with a tension. So this would be a 2 right in there. Should also put in the boundary conditions here that we have around here. So we have ROY and ROX. All right, so when it comes to, yeah, let's go ahead and put in red. Here is our MAT. Here's our MAN. And we'll establish a coordinate system. Did I bother with the coordinate system? I guess I don't have to. I could. I'm not necessarily using tangential, normal tangential anyway. But anyway, this is, let's see, is equal to m times L times theta double dot, right? The tangential, right? The speed, that L. And somewhere over to the side, somewhere, did I do that? I didn't. I wrote Fs1 was going to be equal to K1 times A times theta. Right, so that's sort of that already assumes the small angle thing, because here's A right here, so this is the distance, let's say, it has traveled right there. It's moved that amount A when it has gone in that direction. And yes, so, and same thing true with Fs2. It's just going to be, one's going to be compression, one's going to be tension, but it doesn't quite matter because they're both going in the same direction when it comes to the sum of the moments. So we put in our sum of the moments about O is equal to, oh yeah, sum of the effective moments. There we go. Let me try that. I usually do this instead, right? Effective moments. So here is our positive, I've decided. And so looking through here, mg is going clockwise, so it's negative mg, and its moment arm is going to be L times the sine of theta. But we already know we're going to get a small angle, so we'll just put a theta in there. And then when it comes to these two forces, they are both going to be times A to be able to get this, but they're also going to have a moment arm, right? So there's going to be K1 plus K2 times A squared times theta, right? And this can be equal to, well, I'm drawing this thing clockwise, so I'm going to go negative ML theta double dot. I think I got it all. So grouping these things together, this has the small angle assumption. We go I'm sorry, ML squared. Yeah, okay, because it was the M times L, but it needed a moment arm, so it had to be squared. And so it's because it's mass times acceleration, but it's the effective moment, so it needs a moment arm on there, which in this case is simply L. So ML squared, that should be a double dot, looks like a dot. I guess I moved the thing around to go like plus K1 plus K2 A squared minus MGL theta equals 0. And so the equation of motion, which is what we were asked for, is theta double dot. I mean, you could call this the above the equation of motion, I suppose, plus square root, no, not square root, sorry, get tired. K1 plus K2 A squared minus MGL divided by ML squared. Is that right? Yep, sure. Theta equals 0. That is the equation of motion. And then if we wanted the natural frequency, we go 1 over 2 pi square root of everything that's up there, right? So K1 plus K2 A squared minus MGL over ML squared. I personally never liked the problems that don't have numbers. I prefer problems that have numbers in them. A lot of times I'll convert these into problems with numbers. Let me see. Let me go to the next video.